Okay, the last thing we're going to look at is stating the domain of a function using interval notation. I set the graphs up for you guys already, and then we'll look at a little bit of a word problem. So, example 5. Let's first talk about example 5, example 6. Let's talk about what restrictions you possibly could have on x from any given function. Example 5 is a linear function. Technically, there's no restrictions unless a restriction is stated. In this case, there is a restriction stated. All right, so f of x equals 5x plus 2. Now, if we graph that, the y-intercept will be 2, the slope would be 5, up 1, 2, 3, 4, 5, right to the right 1, that kind of thing. Y-intercept's 2. All right, old school, graphing, linear equations. There's no restrictions. But according to this, they're saying, yes, there is a restriction. They're saying, oh, we only want the graph between -3 and 5, but including -3. As we learned with interval notation, the way we state that, a bracket represents including the number. So bracket -3, comma, through 5, and it's a parenthesis because we do not include the 5 because it's only less than. Okay, moving on to example 6. A little bit more of a more complicated function. I went ahead and graphed it for you. You guys are welcome to use Desmos, but you can also use your TI-84 into the function. Make sure you put the 2 minus x in parentheses and the 2 plus x in parentheses. I know that was a problem in the past, but you can go to your TI-84. We don't use the 83 anymore, or the 89. It's an F1, or you push y equals and you enter the function. And then you hit graph. Now you got to kind of know what the graph looks like. There's something called zoom fit that you could do. I can show you guys in class, but you got to know basically what the window should look like for it to show up. All right. Anyway, the graph will look something like this. Now, with this function, we can actually look at the denominator and we say, hey, we know that we cannot divide by 0. So I need to cut out anything that makes 2 plus x equal to 0. Well, if I subtract 2 on both sides, I would have x cannot equal -2. That's where I get this. That's the old school algebra 2 way of writing it. All real numbers except x cannot equal -2. All right? Because if I use -2 for x, if I plug it in for x, I will get 0 in the denominator of a fraction, which is not allowed. Okay? So, what does that look like then in interval notation? Well, I can have everything except for -2. So according to my graph, I have the asymptote here. I put a little sketch here. Everything is good except for -2. So from -infinity, get rid of that bracket. Now infinity always has a parenthesis. So from -infinity, that's all the way out here. Everything way out here. All the way up to -2. And then we put the union with that of -2. So -2, that's from here on way out there to positive infinity. So interval notation, that is what it should look like. Keep in mind, we only cut out -2. In the past, I know what students have done. Listen to me closely why this is wrong. They would put -infinity to -1, then union it with -3 to positive infinity. And they say, oh, I cut out -2. Well, no, you didn't only cut out -2, you cut out a bunch of other numbers, small numbers, between -1 and -3. Like, for example, if you think about it, if this were -1 here and that were -3, think about all the small decimal numbers that are between -1 and -3. 2.1, -2.1. That should have been okay. Only thing that's not good is -2. So just be careful of that. A little bit more with your calculator. 84 is to enter in a fraction without a parentheses. If you didn't want to use a parenthesis, you can use this alpha or math, NUM it says. You could do that if you want. Otherwise, I just use the parentheses. Example 7. All right, I went ahead and made the graph for you. It's the absolute value, the square root of x minus 3. Square root of x minus 3, it will look like this graph here. Now, I want you to think about the square root. The square root, you can only take the square root of numbers 0 or greater. So x minus 3, no matter what, x minus 3 has to be greater than or equal to 0. I can't take the even root, in this case square root, I can't take the even root of negative numbers. So no matter what x minus 3 were to come out to be, it has to be 0 or greater. So if I add 3 to both sides, I end up with x is greater than or equal to 3. So this is another one, all right? So first we talked about a linear function. There's really no restrictions on linear functions unless stated. Rational functions, in this case, rational functions are fractionals, all right? The denominator cannot equal 0. That's the restriction for that one. Now we're on to roots. Even roots, we call this the radicand. X minus 3 is called the radicand. Has to be greater than or equal to 0. Cannot be negative. And so now in interval notation, everything x has to be greater than or equal to 0. So I will put a bracket, 3 to infinity with a parenthesis. Final answer. Okay. The next one's an odd root. Odd roots, so because it's a cube root, right here, it's a cube root right there. Cube root has no restrictions. Odd roots have no restrictions on the domain. So guess what? Odd root would be everything. Negative infinity to positive infinity. There's a little graph of what it could look something like. That's just a sketch, though. It's not the perfect graph. Right. Example 9. Example 9 has a combination of two of them that I've already told you about. It has a fraction and it has an even root. So when you have a fraction and an even root, you still got to talk about the radicand, x minus 3. But now, before when it was an even root, it had to be greater than or equal to 0. So first of all, it has to be greater than, but it can't be equal to 0 because the fraction. So now we have two things that's coming involved. So like the first one up here, x minus square root of x minus 3 had to be greater than or equal to 0 because 0 was good on that one. But on example 9, it still has to be greater than or equal to x minus 3, but it can't be 0 because of this fraction. So it's a combination of example 7 and the fraction example 6. And so we just say greater than 0, and if I solve that, x would have to be greater than 0. So let's write that. Oh, excuse me, x has to be greater than 3. So if I put that in interval notation, instead of a bracket on 3 like it was in example 7, it will be a parenthesis. So 3 to infinity. Example 10, a little bit more complicated, another rational function, but in this case, it has a quadratic polynomial in the denominator. And so what I did is I said, okay, I'm going to factor that. I factored it to x minus 6 and x plus 3. And now think about what would make your denominator 0. It's a fraction, all right? X minus 6 cannot equal 0, and x plus 3 cannot equal 0. And so if you solve those, x cannot equal 6, and x cannot equal negative 3. Now I went ahead and put the graph. You did learn a little bit of this in Algebra 2 and FST. The graph would look something like this, Looks like a little U shape in the middle. And the graph cannot be 6, so I put a dotted line or an asymptote at 6. And I put an asymptote, it can't be negative 3, put an asymptote at negative 3. All right. Now to make it easier to put your interval notation or restrictions on the domain, I put a number line. All right. Put a number line. I said, okay, this might help you guys sometimes. It can't be negative 3, so open circle. It can't be 6, so open circle. And that's the only thing that it cannot be. Okay, so let's think about it. What's way out here? Negative infinity. What's way out here? Positive infinity. So everything is good except for negative 3 and 6. So let's go ahead and put down our domain, but in interval notation. So to start off, I'm going to start from left to right. Negative infinity is good. All the way to negative 3, but not including negative 3. Union, again, negative 3 is not good. That's what the parenthesis means. But everything to 6 is good, but not including 6. Union, again, 6 is not good. All the way through infinity, which is good, but infinity always has a parenthesis on it. Final answer of your domain, interval notation. Number lines sometimes do help you if you work left to right for any of the examples. Let's look at a little word problem. Won't spend a whole lot of time on it, but I do want to show you a couple setups for the piecewise. Cost of a hotel stay. A hotel chain charges $75 each night for the first 2 nights. The way I do word problems is I just immerse myself in the problem. Imagine that you stayed at the hotel chain for 2 nights. All right, so $75 each night for the first 2 nights. And then if you stayed extra, it'd be $50 additional. So $75 the first night, $75 the second night, then after that it's $50. The total cost T is a function of the number of nights X that a guest stayed. So evaluate the expression for the following piecewise function. All right, so the first one is just 75 times X if you stay between 0 to 2 nights. You stay 2 nights, you stay $75 per night. But if you stay more than 2 nights, that's where it's X is greater than 2. You stay more than 2 nights, well, now you say, okay, if you stay 3 nights, first you got to pay the 2 nights first. That's what the 150 comes from. That's the first 2 nights. And then you pay each additional $50 per night over 2. Another way to write that is just like this. All right? Doesn't matter about 0, doesn't matter about 1, doesn't matter about 2. All right? That will get you back to the $75 or $150 a night. All right? This one only works, the second one, or one only works if it's over 2. All right? So now if you stayed a third night, first you got to pay the $150 for the first 2 nights. And if it was 3 nights, you do 3 minus 1, which would be 1. So 1 times 50 would be 50, so $50 for that third night. All right? So you can kind of see now how to evaluate. T of 2, T of 3, T of 5. All right, T of 2, you use the first one, 75 times 2. That'll cost you $150. All right, third night, that's going to be 50 times 3. I'm going to do that a little bit different, sorry. I'm going to do the second one, $150 plus 50 times 3 minus 2, which gives you 150. 3 minus 1 is 1, or excuse me, 3 minus 2 is 1 times 50 is 50, costs you 200. And last 5 nights, 150 for the first 2 nights, plus $50 each additional night, so that'd be 5 minus 2 equals, so that's going to be plus 50 times 3, that's 150 plus 50, which is 300. No problem. And the last thing I'm just going to show you is just how to darken your screen, the screen intensity. If you have the 84, if you hit the second up arrow and hold it, it'll make it darker. If you hit second down arrow, that'll make it lighter. All right, you can either second up, or second and hold up, and it'll make your screen darker or lighter. Just try it.